2024 A-Level Combined Mathematics Paper 1 Part A question number 4. This question has to do with the binomial expansion. The question says, show that the constant term in the expansion of 1 plus x cubed times x minus 1 over root x raised to the power of 9 is 93. Which basically means if you consider the expansion of this thing right here, the sum of all x to the power of 0 terms in the expansion is going to be equal to 93. Now, in order to prove that this is the case, what we're going to do is to first expand this expression right here, and then by expanding it using the binomial expansion, we can then multiply that common term with this expression right here, and then consider the possible results that we could get, consider which of those results would give us an x to the power of 0 term, add them together, and see that our result is going to be equal to 93. Now for the first step, in order to expand this thing using the binomial expansion, we need to write the binomial expansion. The binomial expansion states if you have a plus b raised to the power of n, this is going to be equal to the sum of terms sigma from r equals 0 up to n of n choose r times a to the power of r times b to the power of n minus r. Now in this particular case, this means that when we expand this thing, it's going to be equal to the sum from r equals 0 up to n, which in this case is 9, so 0 up to 9 of n choose r, which is going to be 9 choose r, a to the power of r, b to the power of 9 minus r, where a is going to be equal to x and b is going to be equal to 1 over root x times negative 1. So we can have negative 1 over root x. So due to this, we can say the common term of the expansion of x minus 1 over root x raised to the power of 9 is going to be equal to, and if we consider taking out the sum and just taking the common term on the inside, we're going to get 9 choose r times a to the power of r, which is going to be x to the power of r, so x to the power of r, times 1 over root x times negative 1, or negative 1 times 1 over root x raised to the power of 9 minus r. Now the reason I divided like this is because I can take the negative 1 out separately, and I take the 1 over root x separately and take each of them to the power of 9 minus r. So doing so, we can see we're going to get negative 1 to the power of 9 minus r times 9 choose r times x to the power of r times this thing, which here we can see 1 over root of x is going to be equal to x to the power of negative 1 over 2. And therefore, if we take that to the power of 9 minus r, we're going to have x to the power of r divided by 2 minus 9 divided by 2. Now doing so, if I do the substitution, we can see we're going to get x to the power of r divided by 2 minus 9 divided by 2. And taking these two terms, we can see when we multiply these two terms together, their powers are going to be added together, and therefore the final result here is going to be equal to negative 1 to the power of 9 minus r times 9 choose r times x to the power of 3r divided by 2 minus 9 divided by 2, because if you add these two together, r plus r divided by 2 is 3r over 2. So now we have this expression right here. Now considering that, we need to then multiply that expression by 1 plus x cubed, and then what we want is to find the x to the power of 0 terms that may result from that. So now due to this, we can say, therefore, considering 1 plus x cubed times that term of x minus 1 over root x raised to the power of 9, considering this thing, constant terms arise when, and considering this thing, since we have 1 here, when we multiply 1 by the constant term in this expression, we are going to get a constant term as the final output. And due to that, if we have this expression where the power of x is equal to 0, then we are going to get a constant term. Now similarly, since we have an x cubed here, in order to get a constant term from the overall expression from this x cubed, we need to multiply the x to the power of minus 3 term from this expression right here. And due to that, the power of x in this expression right here should be negative 3. And due to that, the power of x in this expression right here can be either equal to 0 or negative 3. When it's equal to 0, that multiplied by the 1 here is going to give us one constant term. And when it's equal to negative 3, that multiplied by the x cubed is going to give us another constant term, and those two added together is going to give us our final constant term. And we can see, since there are no other terms in the first thing right here, there are not going to be any other constant terms coming from the second expression. Now due to this, we can say arise when, constant terms arise when the power of x is equal to 0 and equal to negative 3. So we can say 3r divided by 2 minus 9 divided by 2 is equal to 0, and when 3r divided by 2 minus 9 divided by 2 is equal to the other value, which is negative 3, because when it's equal to negative 3, that power of x multiplied by the x cubed is going to give us another constant term. Now solving for the first one, we can see if 3r over 2 is equal to 9 over 2, if we take this to the other side, we can see multiplying by 2, these two cancel, giving us 3r is equal to 9, and therefore r is equal to 3. So therefore r equals 3 is going to be one solution that gives us one constant term from this expression. Now for the second one, we can see taking this 9 over 2 to the other side, we're going to get 9 over 2 minus 3. 3 is 6 over 2, and therefore we're going to get 9 over 2 minus 6 over 2, which is going to be 3 over 2, and therefore 3 over 2 r is going to be equal to 3 over 2, and therefore r is going to be equal to 1. So from this we can see r equals 3 and r equals 1 are the two cases in which this expression gives a x power that is going to be multiplied by this thing in order to produce a constant term. And due to that, we can see the term produced when r is equal to 3 plus the term produced when r equals 1 are going to add together to give us the final term, which is the constant term. Now considering these two, for the r equals 3 case, we can see for r equals 3, the term we get is, and if we consider this thing right here, we're going to get negative 1 to the power of 9 minus r, so we're going to have negative 1 to the power of 9 minus 3, and then we're going to have 9 choose r, which is going to be 9 choose 3 times, and then this power here we know is going to be x to the power of 0, since x power of 0 is what got us r equals 3, so we're going to have x to the power of 0. So now simplifying this thing, we can see we have negative 1 to the power of 6, which is going to be 1, so we can cancel it out, and then 9 choose 3 is going to be equal to 9 factorial divided by 3 factorial, 6 factorial. Now considering this thing, we can see 6 factorial and the 9 factorial can cancel to give us 9 times 8 times 7, and considering the 3 factorial is equal to 6, and we can see in the 6, we can take a 3 and cancel it for this thing, leaving us with 3 here. We can take the remaining 2, cancel for this thing, leaving us with 4 here, so we have 3 times 4 times 7, which is 12 times 7, and as we know, 12 times 7 is equal to 84, and therefore the term we are going to get here is going to be equal to 84. 84 times x to the power of 0 is going to be 84, since x to the power of 0 is equal to 1, and therefore the term we get here is 84. Now considering the second term, for r equals 1 term, the term we get, the term is negative 1 to the power of 9 minus r, which is going to be negative 1 to the power of 9 minus 1 times 9 choose 1 times x to the power of, and here we know x power is going to be negative 3, so we have negative 3 times x to the power of 3, which is going to cancel out, leaving us with x to the power of 0, or just 1, and considering the rest of it, negative 1 raised to the power of 9 minus 1 is negative 1 raised to the power of 8, which is going to be 1, so therefore this is 1, we can cancel it out, and this thing right here, 9 choose 1, any number n choose 1 is going to be n, and therefore 9 choose 1 is going to be 9, so we have 9 times 1, which is going to be 9, and therefore the term that we get here is 9. So we have the term 84 coming from r equals 3, and we have the term 9 coming from r equals 1. And these two are the only two constant terms that are going to come from 1 plus x cubed times x minus 1 over root x to the power of 9. And therefore we can see, therefore the total constant term is 84 plus 9, which in fact is equal to 93, and therefore the overall constant term is in fact 93, and hence we have shown what they asked us to find. We were asked to show that the constant term in the expression is 93, and we have done so. So with that, we have completed the question. Now finally, let's take a look at the marks awarded for this question. So for this question, writing down the binomial expression actually doesn't get you any marks, but instead, when you either write down the substituted binomial expression or you write down the common term in the binomial expansion of x minus 1 over root x raised to the power of 9, writing this thing right here gets you 5 marks. Now after that, When you simplify this down and take this term right here, the x term here, and the x term here as a single x term, as you take the two indexes and you combine them together to get a single x term with a single index like this, getting to this point right here gets you another 5 marks. Now after this, when you differentiate the two cases where you're going to have two different values like r equals 3 and r equals 1, for differentiating and finding each of the relevant constant terms as 84 and 9, for this bit and this bit you get a total of 5 marks, and for this bit where you find r equals 1 and the corresponding constant term you get another 5 marks, and then when you add them together show that the final answer is in fact 93 and the overall constant term is 93, you get another 5 marks for that. So that's going to be all the marks for this question, and that's going to be all for this video. So I hope you enjoyed. If you have any feedback, post the comments down below. Thank you for watching, and goodbye.